which is a swarm-based algorithm. And then also, I want to show you within this video, I think something that I'm 99.9% sure you're not going to see anywhere else. And so let's go ahead and dive into it first. The first example that I'm going to show you is a swarm algorithm that I personally made, and it's called Penguin Swarm. And then it's so with swarm algorithms, they initially came about based off of examining swarm behavior in animals, right? So like bees, there's like bee swarm. Another common one is there's like a ants and like some type of like firefly, like organisms that are necessarily swarm based, and then so they like the bees was like the first one, right? And then so that's kind of like the most common one. But so the idea is that you model whatever the specific behavior is of that organism, and you can create like generations of the organism, right? And then so based off of that behavior and based off of like fitness scores of the behavior. So a lot of algorithms a lot of swarm algorithms, they'll operate off of like pheromones, like digitalized pheromones essentially, and that process is what drives like um, generational enhancement, and then you also put like a little bit of randomization in there, etc. And then so you kind of you blend your algorithm up, but in general, your algorithm is essentially just really based off of an organism. And then so in this instance, I decided to base my organism for this particular algorithm off of penguins. And then so penguins have essentially like three behaviors that they partake in. They huddle, they forage, and they breed. And then so huddling, they huddle for warmth. Foraging, they'll go out and they'll forage for food. And then at breeding, they have a specific ritual that they do, which is that they exchange pebbles. They have a pebble exchange, right? And then so my algorithm does this. like it you start swarms, which is like you start like a bunch of algorithms, like agents, which we'll dive into in a second. And then the agents, in this particular instance, they go through and they perform their different tasks. They huddle, they forage, and they breed. And then the breeding is the passing of a pebble in this instance. And then so and then there's a fitness score that each generation gets based off of that. And then so the most fit ones, like the ones that huddle the best, that forage the best, and are the best at the pebble exchange, then they get passed on to future generations, and then the algorithm essentially like evolves from there. And so, in a nutshell, that's like what the penguin swarm algorithm is. And then so, this is the complete text of the penguin swarm algorithm, and then it's very straightforward overall, right? And this is what I like. I love. I absolutely love this about swarm algorithms is that I'm not utilizing any GPU whatsoever, and then when I run our penguin swarm algorithm here, I've already run it, and it's less than a gig of RAM that it took, right? And just pure CPU. And then so, and this is like our, it's exactly what I just described, right? Like generational creation of a swarm of penguins. And then they have a foraging behavior. And then so for foraging, they can dive, they can follow, and they can explore, and they do different things. And then so for breeding, it's the passing of the pebble. And then you have updating trails, and then you get the fitness function, and then essentially they're breed and based off of the fitness function, and then you create and you define your individual penguins, and then the full swarm, and then they all go out and then they swarm, and then so I create in this instance I've created 1,000 penguins, right? And then so the 1,000 penguins, they go out and they do their thing, and this is not computationally expensive at all. So like that's the number one thing that I love about this. It's um, very it's cheap as far as resources for the computer, right? And then so kind of think of this outside of now. Let's think of like these swarm algorithms. We don't necessarily have to think about them as animal traits and animal characteristics. That's how this all started, right? They started off in this arena, but you can do anything with swarm algorithms. Like it's what you do with the algorithm. you can do whatever you want with it, and it's up to your imagination how deep you get into that. And then so diving into that, let's go ahead and take the swarm algorithm out of like the animal kingdom, and then we're going to bring it into an instance here where I think like you haven't you've I'm 99% sure you're never going to see this and have never seen this, which is swarm-based algorithms performing function calls like API calls, right? What people want LLM models to do, what everyone is like the everyone is going for like that as the key, right? Like get an LLM model to do this, but it's I mean, why do I need to get an LLM model to do this when I can get my swarm algorithms to do this? And my swarm algorithms could run off of a calculator and do the job that you want LLM models to do, right? So overall, let's describe like what's going on here. Like how do these swarm algorithms arrive at their solution? And to me, it's very straightforward, right? So it's this generational approach where it's you are essentially you define the reward function like in everything else that we've talked about with AI. It all comes back down to this reward function, right? And then you define what the reward function is, and then you kind of breed generations of agents based off of the reward function, and each generation is stronger and stronger and stronger. It's like self-building towards the reward mechanism, right? And then so in this instance, in the end, what we're going to want to do is we're going to want to make an API call. And then so just imagine what we do is we say, okay, we're going to like put out like 1,000 agents, like we had our 1,000 penguins, right? We're going to put out like 1,000 agents, and then we want to make an API call to Amazon. Who cares? And then so 1,000 agents go make the API call, and then like a bunch of them are going to fail, and then the first generation is going to fail because it doesn't know what to do. It's going to, I don't know what an API call even is, and the second generation is going to learn. It's going to be a little bit better because it's going to know, right? And then so we're going to have essentially like highs and lows that are going to be taken within that, and then essentially all we're going to be doing is just shedding the low every time, right? So it's here's the high, get rid of the low. Here's the high. If we get a new high, that's fantastic. Get rid of the low. If we get a new high, that becomes a new benchmark, right? And then just by doing that simple process, like this iterative process over and over and over again, we can come up with whatever the solution is. And so in this instance, our solution is I want it to make API calls. But so let's start off even simpler than that, right? So starting off with the very basic notion of this, I think that to a lot of people this is still kind of maybe Greek over your head. So let's kind of try to like bring this down a little bit. So let's talk about a basic swarm algorithm performing a basic function. And then so within this, it's very straightforward. First of all, we have to define our agent, right? So we define our class of our agent. And then we define functions for the agent to do. So in this instance, we have subfunction 1, subfunction 2, and subfunction 3. And then we have our agent class. And then so our swarm is made up of individual agents that perform individual subfunctions. And that's essentially all that we're doing here. And then so our next step then is to create the swarm function. And then so within this, within this particular swarm function, we're just combining our 3 agents, right? Agent 1, agent 2, and agent 3. And then for the subfunctions, each individual agent has something in this instance, pre-programmed that they're doing. So agent number 1 is taking whatever we put as a base number into this, and they're adding 1 to it. Agent number 2 is taking whatever number it is and multiplying it times 2. And then agent number 3 is taking whatever number it is and then they're minusing it by 3. And then so that's all that the agents do. And then our swarm function combines the agents, randomizes the agents, and then randomly iterates over those agents. And then so I'm creating essentially like a pseudo random output based off of that formula, right? But it's like the logic is straightforward as to exactly what these agents are going to do. So we could always trace it back, which is what makes it pseudo random. But it gets us a somewhat random result, right? And then so that's what we see here is that we have our combination of I put in the number of 5, and then the agents execute, and execute it on a random number of times. And then so we get the end result numbers, and then we combine those the sequences, and then we get our final result. And then let's say we want to make it a little bit more complicated. So in this updated version, we're going to add some new subfunctions. We're going to add an additional subfunction 4 and 5. So we're going to add 2 more agents. And then we're going to create dynamic agent creation, which is based on the initial output, the system will dynamically add agents. And then so it's going to, rather than just iterating over and over the agents, it's going to add more to the initial pool. And then we're going to add some sort of collaboration. So in the beginning, we had just, here's the 3 combined outputs. In this one, we're going to have them, the results of 2 agents will be combined to calculate a new value. And then that'll be like an inter-agent communication, right? Like an inter-agent output. And then we're also going to put some result handling within this. So the system will store and print the results of each individual agent's execution, so we can take a look more in depth into it. And then if we look at these agents, so the first 3 are essentially doing the same thing, the +1 times 2 and -3. And then our second agent is also doing a multiplication of times 2, and then our fourth agent is, and our fifth agent is dividing by 2. And then so our fourth agent is going to multiply twice times 2. And then so we go through, and then we have our dynamic outputs. We can see that we've dynamically, in this instance, added our agents 4 and 5. And then we give them random input numbers, so that they have random numbers that they're starting with on top of the initial input of 5. And then we let them go, right? That's how we're just making sure that we're inputting the randomness in here. We have our swarm function, which is defining our agents, and then that random shuffling, and then also that random creation of and adding of the agents, right? And then so we've got that here. And then we can see here, so the final result is agent 2, agent 3, agent 1, and then we combine those, and then we get randomized from that, and then we get our output and our result. And then so again, it's just a little bit more complex as far as the randomization. And then so let's take it essentially a step further from here. And then so the step further from here in this more complex example, we're going to operate on a list of values. So we're going to take a list of data instead of one single value. So instead of 5, we're going to it'll be 1, 2, 3, 4, 5, 6, 7, 8, 9. And then the subfunctions are each going to perform different mathematical equations. They'll do the same things, but we'll add more, right? We'll add sine and cosine, etc. And then we'll add maybe some reciprocals. And then we're gonna, with our agent function, it's gonna update dynamically. So rather than just randomly adding agents at random intervals, it's gonna update dynamically based off of the different conditions and the input data. So it's gonna essentially be reading the environment, and then based off of the environmental outputs, then that's what it'll decide and how it'll decide to assign agents and to generation. It's going to have some sort of generational guidance as opposed to just randomly generating generations, right? And then essentially from there, we're going to have that if any value is negative, we're going to change and we're going to manipulate. So essentially, we're going to add some additional logic and some additional checks to our logic here, just to make sure that our generations enhance and grow each generation. That's the goal with this, right? Is that our generations get better over each generation, and we're just very specifically driving that, natural selection, right? And then so when we go through here and then we run the code, we can take a look, and then it's essentially the same. It's the same formulas that we've been working with, but then we're adding just more variables and more functionality to what they're doing, right? So we're saying not only are you just multiplying by 2, but you're also trying to solve for x, and so some sort of increased complexity there. We start off with 4 agents, but then again we want it to add agents, and then so we can go up to 8 agents here, and then we can add agents generationally, And then we can go through and then we define our swarm function. And then so you can see each one of these is getting like more and more complex as we go through, right? And then our initial input, again, like I said, not just that single number. It's 1 through 10. And then so we spit out and then we get our final results. And our final results are like a lot of mixed numbers, because so in this where we have like it's this generational blending, right? So then they're combining, like it's not just agent 1's input and versus like agent 3's output. It's like agent 3, agent 5, and agent 7's output combined to 5.22, 549, etc. Right? And then so there we get that going on, and then what that allows us to do is we're kind of more our goal really is to optimize as much as we can, right? To get like maximum optimization of our values. And then so with this, we've been, and up until this point, we've been playing with numbers. And then so that makes it kind of abstract. So let's go ahead and actually like take a look at this more as a like a real world example. And we'll take a look at like an actual function call. So instead of getting our agents to produce the number output, we want it to produce a function call, and then an API call, right? So in this instance, so we in order to do that, we have to install one more package. So we're going to install requests, and then we're importing random, and then from there we essentially define our agent class like we've done, and then our subfunction in this instance is to call a specific URL. And then so in this instance, I'm very specifically giving it like these specific URLs to call, and then I'm saying call these URLs, and then I want status 200, which would be success status, and then have the individual agents call the individual functions within our call these individual URLs, right? And then that's essentially what it does. And then we want to combine the result there. And then so we combine the result. And then so this is the data that we're getting back from those URLs, from those function calls, right? And then so like this is a good start. Like, this is the data that we like. This is actual data that it pulls back. So user ID 1, title, completed false, and so these are like this is an actual sample URL API that you can use for things like this, right? So it's going to return data like this. Like this is actual data that it's returning. Like I didn't make up any of this. this is all data that's getting returned, right? So you've got the name, email address, street, email, and this is again all made up data, right? Zip code, etc. Right? And then so, but that's what you want. And then so we can see it is actually like our agent swarm, just like our little agent guys are pinging these URLs and bringing back data, which is that's what we want, right? So then this is good. So we know we can do this, right? So let's put it all together, and then let's say, hey, let's build an API agent swarm. And then so that's what we do here. We have a few more imports. So we have our random and request just like we had up there. And then now we're importing a few more things here. And then we're increasing the logic of the agents. And then so you'll see in both the agents in their creation as well as their execution, you'll see these kwargs arguments. And then so these kwargs arguments are like very specifically like giving the agents a lot more logic within this instance, right? Because so essentially what we're doing, if you look here, I've just got the URL, right? And then so I've got the base URL that I tell it to go to, and I tell it that there's some endpoints here at the URL, that there's a to-dos endpoint, a user's endpoint, and a post endpoint. And that's all of the information that I'm giving this thing at all. Like I'm not giving it anything else beyond that. And then I say I want you to get those results and organize those results. And then so, and each agent you go through and I want you to get me some stuff. And then so agent number 1, user ID, title, completed. Agent 2, ID, name, username, address, street, suite, city, zip code, geo, latitude, longitude, phone, etc. So, I mean, again, we're like, uh, this is the actual like data being pulled from our swarm agents, like from this particular API, and then you can see like there is like we would in a production setting we would want to clean this a bit. Like we would want to make sure that it's like these last three outputs that we probably aren't getting those. Like, but these up here, like this is money. This is what we want, right? This is what everyone wants right here, and this is what everyone is wanting LLM models to do. But why do you need the LLM model to do this part of it? To me, and that's kind of like the big thing I want to end this video on is, so to me, LLM models, they're good at planning, right? So uh, what an LLM model and what the LLM model should do in this instance is provide the model with this, right? The LLM model will pass these instructions. Hey, Swarm, here's what I want you to do. Here's the URL that I want you to go to. Here's the endpoints that I think exist there. Check for more endpoints for me, and then update me. Let me know what other endpoints are, and I'll get back to you and see if I'll tell you if I want you to update this or not. But then that's really it, right? And then also update me with the IDs, and then so the LLM model can then update this in real time and say, okay, like go back to ID number 5544. That's the one I was looking for, I think. Tell me more about that one. Okay, that's maybe that's not the one I was looking for. How about 4205? That looks like a kind of similar pattern. And then the AI could go, and it's so essentially what you're doing is you're still utilizing the LLM model within this equation, but only for this. Like this is the part where the LLM model is good. The LLM model is not good at the actual execution, like this, like pulling these results. But swarm algorithms, as we're looking at here, and like again, like the resources that are used by this is almost nothing, right? I don't have to connect to any GPU, nothing like that. It's just all pure based off of the CPU and like less than a gig of RAM. You can run it on a TI-86 calculator and then get this. So this is the way to go to me, as opposed to trying to get the LLM model to do it all. And so I hope that you like that this inspires at least someone in this direction, because I don't like, again, like no one is looking in this direction because everyone's enamored by the LLM model. But also too, the big thing is just to show you exactly what you can do with swarm algorithms specifically and with algorithms overall, just with your imagination. Like all this boils down to algorithms at the end of the day, right? So all of this is an algorithmic discussion at the end of the day, and then hopefully this gives you and shows you the power of algorithms and the power of swarm agents. Thank you very much.